Hello, and welcome back to the channel. My name is David Young, and this is episode 3 in my Software Engineering Basics series. Today, we're going to be talking about software processes and methodologies. That is, how software engineering principles are implemented in practice, and some of the models and methods that are used. We've already talked about an overview of software engineering and the difference between software engineering and software programming. If you'd like to see those videos and you haven't already, please go ahead and go to my channel and watch those before you watch this video. Next up, we'll be talking about real-world software costs. And finally, we're going to be talking about software engineering's challenges and professional issues and how some of those are going to be addressed. Before we begin, I'd like to ask that if you enjoy this video, that you would like, subscribe, and share it so that more people can learn about software engineering. Thank you. So we've talked a lot about principles and ideas behind software engineering. But what does software engineering actually look like in practice? We're going to talk today about 4 models and methods that are used to implement software engineering. The first is the waterfall methodology. In this methodology, projects are divided into sequential stages. So you can see, for instance, over here, that we start by gathering the requirements. Then we move to design, implementation, verification or testing, and then deployment and maintenance of the product. Each stage is fully completed before the next begins. So there's not any movement back up this waterfall. Just like in real life, you can't swim up a waterfall. Once we've finished up the requirements, we're not going to return to that stage. Once we've wrapped up the design, we're not going to reevaluate that. We're moving through this procedurally and sequentially. And so because of this, because we're not going back and looking at the stages we've already completed, it's really important that we get it right in this first stage and in the second stage. So having clear requirements, communicating with the customer and making sure that everyone understands what the needs of this customer are, and then having a strong design that's going to guide the implementation of this project is absolutely crucial in the waterfall model. So there are some pros and cons to this method. The first pro is that it can produce an accurate estimate of development time and budget because everything is separated out into these rigid categorizations. It's going to help provide your customer with an estimate of when is this project going to be completed and how much is it going to cost, which can be a pro for communicating with that customer and for knowing for yourself what the project timeline is going to look like. It also minimizes communication overhead because a strong design is emphasized and everyone, by the time implementation is going on, understands exactly what is needed for this project, what's going to be expected of them. Some of the communication overhead, which is the time that it takes to have collaboration and communicate with your team members and get on the same page, is taken away because there's a clear roadmap for the project and everyone is filling a role that has been defined by the design of the project. Also, strong planning catches errors early. So an error is not going to go, ideally, in the waterfall method unnoticed. It's going to be caught by careful design, and that's going to save a lot of headaches down the road. But there are some drawbacks to the waterfall method, and in fact, this method is usually regarded as extremely outdated in the software world. The first is that the waterfall method is extraordinarily rigid. And the upshot of this is that changing the requirements or the design is costly. If you get to the implementation stage and things aren't panning out like you had hoped, or if the customer decides that they want something different, it's going to be costly because the waterfall method is not designed to go back and reassess those requirements. It's designed to proceed in a very linear, fixed way. And this means also that delays in one stage delay the entire project. Rather than having all of the stages going on at once or having an iterative process, as we're going to talk about in a minute, uh, a delay in the requirements gathering or the design phase is going to propagate to all of the rest of the phases, and there's no way to spend time doing other things because everything happens sequentially. It also may take longer than iterative processes like Agile, which we're about to discuss. It's just shown that this method is not the fastest. And so generally, this is not something that's undertaken in the world of software engineering. The Agile methodology developed in response to the stringency and stricture of the waterfall method. You'll see here how it's represented by the cycle, because a crucial aspect of the Agile model is that it is iterative. So these processes, which were in the waterfall model, were sequential of planning and designing and developing and then testing and then finally deploying, are actually happening in a loop in the Agile method. These iterative phases are called sprints, and they're typically 2 weeks long. The Agile methodology emphasizes communication and collaboration. So it's very important. It's not so important that a strong design be established as it is that communication and collaboration between team members are being fostered and that customers are able to voice their concerns and their desires and have those considered and implemented even late in the project. And so this all leads to projects being intentionally flexible with room for changing requirements even late in development. It's more fluid and flexible than the waterfall method, and it encourages that fluidity and the creativity that often comes from working together and adapting and being ready to switch on a dime. It also has numerous sub-methodologies. So Scrum and Kanban are two of these. So Agile really refers to is an umbrella term. It refers to a broad range of methodologies. Let's look at some pros and cons for Agile. The biggest pro and the reason that Agile exists is because it's flexible and adaptable. And so it's going to lead to greater customer satisfaction because they're going to have more control over changing requirements and they're going to have more communication with the team. It also means that setbacks are able to be handled more gracefully. So rather than delaying the entire project, as in the waterfall method, these setbacks are not going to be as catastrophic because the Agile model is not based so much on a strong, rigid upfront planning as it is on flexibility and collaboration. It also means that there's not as much overhead in planning and documentation as we just talked about. Agile actually de-emphasizes documentation and planning, not making them irrelevant, but subordinating them to a desire for collaboration and strong communication. And also, as we've been talking about this whole time, the Agile method is conducive to collaboration. And of course, this is going to generate new ideas and better solutions than individuals working in isolation. Additionally, core features are tested many times in the Agile method. So what happens is that the most essential features are developed in the first sprints. Those are presented to the customer, and then subsequent features are built on top of those core features. And what this means is that as those subsequent features are tested, the core features are tested as well. So this is going to provide a really robust end product. A con of the Agile methodology is that it's just really susceptible to scope creep, which is when a project keeps having requirements added to it and throughout the process until it's way bigger than the initial estimate. And as a result of this, the timeline for the project and the budget are really hard to estimate or control in Agile because you're not going in with a strong plan, but you're developing, and the project is often ballooning throughout the process. It's also true that because Agile emphasizes collaboration and working code more than documentation, it may hurt your maintainability in the end because you don't have strong supporting documents for your code that explain how it works. And especially as your teams roll over, that can be a problem. It's also true that because the agile method relies so much on communication, there can be lost time in waiting for responses and decisions. Although typically agile attempts to address this by emphasizing face-to-face meetings and direct interaction rather than, for instance, an email or a memo, uh, because this minimizes the time wasted waiting and responding to emails and things like that, and gets teams where they need to be for software engineering, which is programming and planning and thinking. The DevOps methodology is almost a further iteration of Agile, and we'll see that it's very similar. And you can see in this model here that we have that DevOps is depicted in the same way as being cyclical like Agile, but DevOps has particular emphases that emerged and that are going to attempt, in particular, to make the maintenance phase more integrated with the rest of the project development. So the reason it's called DevOps is because it emphasizes increased collaboration between the development side, the dev, and the operations side, which is the maintenance and IT side of software engineering. So rather than having a separate development team that's going to develop the product and then push it out, and then the operations team takes over and makes sure that that product is working, it's more like this infinity symbol where the development and operations teams are working together to revise and improve the product throughout its life cycle. So it's going to emphasize short iterative development cycles and pushing releases to users quickly. So what this looks like is frequent updates and developments based on user feedback and based on bug fixes. And this is going to result in the product getting into users' hands quickly, but also a sense that the user is being heard and that the product is living and is being worked on. A key feature of DevOps is that it's going to rely on tools to automate and to increase efficiency. So, for instance, Git, which is GitHub is maybe something that you've heard of. Automated testing, so taking the human time delay out of testing the product and putting simple tests onto an automated system. Having things like telemetry on the product to make sure that it's working as intended. And when it's not working, because of the strong relationship between the development team and the operations team, those bugs can be addressed quickly, the code can be fixed, and then that release can be pushed out to users. And then it's going to also rely on platforms like Jira, which is a project management tool, but it also includes a framework to manage DevOps operations effectively. Some pros and cons of DevOps. The number one pro that is cited over and over again is that it's efficient. It focuses on getting releases to users quickly, and it focuses on fixing bugs quickly because the operations and the development teams are so intensely related. It also means that there's an increased awareness between the development team and the operations team about the impact of decisions on one another, which is going to lead to higher quality software overall. The development team in particular is going to be attentive to how their decisions might affect the maintainability of the software. And this is going to smooth out some of the processes that might be cumbersome when the development team has no comprehension or understanding of what's going on the operations side of things. And it's going to mean that both of these teams are mindful of the user experience more. And that's going to lead to higher quality products. Quick updates and patches to the software. That responsiveness to customer feedback keeps them happy. It keeps the users happy. And so that's going to lead to improved revenue flow, but also just the delivery of a good quality product. Con of DevOps is that it relies heavily on technology, and especially teaching teams that aren't familiar with DevOps can be a challenge because it can slow down the project and increase the cost. There's a learning curve with DevOps, and that can be a big investment to overcome that learning curve. There's also the potential for over-reliance on tools. We talked about how testing gets automated, and while that's good, it can mean that it can foster complacency. among development teams and operations teams rather than pushing for a better quality product. There's an over reliance on technology and tools that means that the product ends up being worse. Additionally, pushing out updates quickly is great, but it could mean that you miss things, particularly security vulnerabilities. Now, there's a discipline called DevSecOps, with sec referring to security, where the security team is looped in also, and all three of these are working together closely. And this is going to attempt to address some of the problems that can potentially arise with these quick updates and changes through DevOps. Continuous integration and continuous delivery is another philosophy and methodology that's used in software engineering. So let's take a look at this diagram up here. This reflects more of an old way of doing code where developers are each given an assignment, for instance, writing a function or a class. They're going to write that code, and then that's all going to be merged together at the end. So they may spend several days, several weeks writing this code. When it's merged, all of this code has to be reconciled, and this is going to be a big headache because if the developers haven't communicated well, as is often the case, big changes are going to need to be made to harmonize all this code. Then the code is built and tested, and further issues are fixed before it's finally ready to deploy. Continuous integration and continuous delivery is going to attempt to automate the process of integrating code. So what's going to happen is that as developers make changes, they're going to commit it to a repository, and the repository is where the code is stored. And immediately upon the code being placed into the repository, it's going to be built and tested automatically to make sure that all that code is working together well, so that there's not this massive reconciliation after weeks of work, but that the code is throughout the process conformed to work together well. It's also going to do some automatic testing before it's released into a test environment and then deployed to end users. And so developers are going to frequently reconcile their code with a repository, and this is what the continuous integration refers to. And then continuous delivery is referring to the fact that code is going to be automatically tested and prepared for deployment. And so it'll be manually tested and improved before it's sent to users, unless you're using continuous deployment, which is similar to continuous delivery, but instead of waiting for manual testing and approval, it's going to just automatically deploy the build to users. Obviously, this is faster, but it can leave some security vulnerabilities and other problems if your automatic testing system is not sufficient to make sure that that code is functioning as it should. DevOps, in particular, relies on CI/CD practices and implementations, but this is also important to a lot of other modern software development because of the fact that it avoids this huge overhead up here in reconciling the code. Some pros and cons of CI/CD are that it's just a massive efficiency boost. Geeks for Geeks notes that it's 25 to 30% faster than traditional software development models. So it's a huge boon to companies and to development teams because it boosts efficiency. It also means that bugs are fixed sooner because they're not left until the end, and they're not left to manual testing, but they're going to be automatically tested, and there's a lot of processing power going into making sure that bugs are checked. It also means that labor costs are diminished because so many of these previously human tasks are automated away. It's going to make your project cheaper overall. But some of the cons of CI/CD are that it relies on technology, and it may require upgrades to technology for the development team or training on new software, which of course, as with DevOps, can mean that there's a learning curve. Continuous deployment in particular. So remember, continuous delivery is simply when the code is automatically prepared and sent to a test environment to be tested. But continuous deployment is when it's pushed straight to users. This can leave security vulnerabilities and other bugs if you don't have that final stage of manual approval. So let's look at an example of methodology in practice. We'll look at Microsoft's live site culture. So this is referring to products that are being used by users actively rather than like Microsoft Word release. But it gives us an insight into a particular instantiation of DevOps. So you can see here some of the crucial aspects of DevOps represented in this diagram. For instance, drive with data and automate to survive. DevOps relies heavily on these automations to deliver key boosts in efficiency. And there's also an emphasis on feel the pain. What this means is that you're aware of the impact of your decisions on the user experience. Remember that DevOps emphasizes the integration of the development team and the operations team. So developers need to be aware of what's happening with on the IT side of things and how their changes are impacting users. And so you can see that reflected in this maxim that you should feel the pain. You should know if you make a mistake, you should be responsible for fixing it so that those development and operations sides of things don't become disparate and developers become complacent and just push bad code out to let the IT team deal with it. So this is just reflective of one particular instantiation of DevOps. Thank you for watching this video. Next up, we're going to talk about real-world software costs. Please, if you have any questions, leave them in the comments, and don't forget to like, share, and subscribe. Thank you.